In this tutorial, the implementation of thermal expansion in model is done with UEXPAN and VUEXPAN subroutines for Abaqus standard, implicit method, and explicit solvers. In Abaqus, UEXPAN or VUEXPAN are user subroutines that define user-specified expansion behavior. They are particularly useful if the expansion behavior is temperature-dependent or varies under certain conditions not captured by Abaqus's built-in material models. Thermal expansion is the mechanical tendency of a material to an increase in size, length, area, or volume, and changing its density with increasing temperature. As we know, temperature is a function of the average molecular kinetic energy of a material. When a material is heated, the molecules begin to vibrate faster and move more. As the energy in the particles increases, they move faster, and the intermolecular forces between them weaken, thus expanding the matter. In this tutorial, the user subroutines UEXPAN and VUEXPAN are used to simulate the thermal expansion behavior of linear elastic materials. The geometric model used in this study is a two-dimensional square specimen under temperature loading. The workshops provide a full step-by-step guide through a video to simplify the simulation of the complicated thermal expansion models using UEXPAN and VUEXPAN subroutines. In the video, how to model, call subroutines, submit the jobs, and extract results is shown in full detail. You can use the concepts taught in this tutorial to implement more complicated thermal expansion behaviors of materials under different processes using the UEXPAN and VUEXPAN subroutines. The UEXPAN or VUEXPAN subroutines are used when the material's thermal expansion behavior is too complex to model with the expansion option in the Abaqus software environment. For example, this subroutine is used in problems where the thermal strains are complexly dependent on temperature, predefined field variables, and state variables. And also, there is a need to update these variables. The project can be highly beneficial to engineers, researchers, and professionals in fields like materials science, mechanical engineering, and structural analysis, particularly when they are working on projects that involve complex thermal loads, material behavior study, high-precision applications, development of new materials, thermal-mechanical coupling. This project is designed to enhance participants' understanding how to accurately simulate the complicated thermal expansion models of the materials using UEXPAN and VUEXPAN subroutines. The basic fundamentals of thermal expansion, the description of UEXPAN and VUEXPAN subroutines variables, and all the UEXPAN and VUEXPAN subroutines used in this tutorial are explained in detail.